Hello my dear student. In previous video we have seen introduction of an array. Now in this video we'll see memory representation of an one-dimensional array. And in next video we'll see memory representation of an two-dimensional array. So let's start for the memory representation of one-dimensional array. So as I told you, array is a collection of similar type of elements and we are storing these elements in a continuous memory locations. Okay, and always your array index will start with 0. So let's take one example. Suppose you want to store 6 elements in an array. First element is 10, then 20, then 30, then 40, then 50 and then 60. These are the 6 elements in array. And array name is A. Okay, so how we can declare it? Int A of 5. Sorry, elements are 6, so you need to mention here 6. 6 elements are there. So this is size of an one-dimensional array. So always your array index will start with 0. So array index for this first element is 0. For the next one it is 1, then 2, then 3, 4, 5 like this. So always array index will start with 0. And if you consider size of an array as n, okay, then last element is stored at index n minus 1. So here what is the n? In this example n is 6. So where is stored last element, at which location, at which index we can say? So n minus 1, that is 6 minus 1. So it is 5. So at 5th index last element of this array is stored. Okay, so in this way we can calculate the last element index of an element which is stored in an array. So elements of an array has a consecutive address. Okay, so we are storing all elements in an array in a consecutive memory location, because this is one of the sequential organization of an data. Okay, so here suppose first element having address as a 1000, then the next element is stored in its consecutive memory location. Okay, so these are the integer numbers. We are storing integer numbers in an array. So to store one integer number in a computer memory, we require 4 bytes. To store one integer number in a computer memory, we require 4 bytes. So this first element required 4 bytes memory, okay, in a computer memory. Now this next element is there, okay, this also required 4 bytes. So what will the address of next element? So address of next element will be 1004. 4 elements for this, 4 elements for this. Then how we can calculate address for the next element, that is the third element in an array. Okay, you need to add again 4. Okay, so address will be 1008. Likewise, we will store all elements in a consecutive memory locations in a computer memory. So address here 1012. Okay, then 1016. Okay, then 1020, like this. 4 bytes we need to add, because each and every integer value, to store each and every integer value in a computer memory, we require 4 bytes. Okay, so in this way we can calculate the address of a element in an array. Okay, so what do you mean by the base address? So address of the first element in an array, that we can say as a base address. So this, in this example, this is our base address. Base address means what? Address of first element in an array, that is the base address. So first element is this one and address of this first element is 1000. So this we can say as a base address. So if you want to find out the address of this element, that is 6th element in this array, we need to add 4 byte and then we can find out. But if there are 1000 elements in an array, can we use this logic to find out the memory address? No, we cannot. So for that purpose, we have one formula, and by using that formula, we can calculate the address of an element at specific index in an array. Okay, so let's see this with the help of formula. Consider one example which consists of 10 elements. Okay, and I already told you index of first element is always 0. Okay, so first element is 10, then 20, 30, 40, 50, then 60, 70, 80, 90, and then 100. 0 index for first element, 0th index, then first, second, third, fourth, fifth, sixth, 7, 8, 9. 0 to 9. Okay, first element having index 0 and last element having index n minus 1. So what is it? 10 minus 1, that is 9. So this is the last element of this array. Now if you want to find out the address of this element, okay, so address of 6 element in an array, how we can find out? So for that purpose we have one formula here. Address of I indicates index, for which index we need to find out the address, equal to base address. Base address means first element address in an array, plus I means index for which you want to find out address, into element size. Element size means which elements you are storing into that array, what will the size of that element, that we need to consider. So in our example we are storing integer values. So for to store integer value in computer memory, we require 4 bytes. Okay, so that will be the element size. So let's see, address of A of I. I'll just write down this formula here. Base address plus I into element size. Okay, so which address we need to find out, at what index? At 5th index, whatever the element is there, we need to find out address for that. So what will the value of I here? I is 5. Okay, so what is the base address here? Consider a base address as 1000. What do we mean by base address? Address of first element in an array. So base address is 1000 plus, what is the value of I for your example? It is 5 into, what is the element size? Element size means elements which we are storing, size required to store that elements into the memory. Okay, so here we are storing integer values, so we require 4 bytes to store into the computer memory. So element size is 4. Okay, so after calculating this is 1000, this is 20, okay, and 1020. Okay, so we can say address of element which is stored at the 5th index is 1020. Okay, so in this way we can apply this formula and calculate the address at this index by using this formula. So this is the memory representation of array in one-dimensional array. So in next video we will learn memory representation of two-dimensional array. If you like my video, please like, share and subscribe my video. Till then, take care. Bye-bye.